Hello, I'm Ted Conway. I'm a longtime SAS user, and today I'll be giving you a brief introduction to SAS ODS graphics and how it compares to the core plotting libraries in R and Python. Now, each of these are topics that can fill 1,000-page books. Since we've only got 15 to 20 minutes, the agenda for today's whirlwind tour of SAS, R, and Python graphics boils down to this. And while actual coding snippets will be reviewed, they'll be kept at somewhat of a hello world level for this presentation. Even among people that don't do graphics programming in SAS or Python, there's this consensus that SAS doesn't do custom chart output, even if they're aware that SAS ODS graphics is behind much of the procedural output they use. Today I hope to dispel that notion and show why SAS ODS graphics should be added to your toolkit if you're not already using it already. So one might question the need for a discussion of introductory graphics coding at a conference of analytics types. But there are other alternatives for producing graphics, such as Excel and interactive data visualization software like Power BI, Tableau, and SAS Visual Analytics. So many haven't yet dabbled with SAS ODS graphics, ggplot2, or matplotlib. And even if you're using one of these, having some familiarity with all three is helpful when it comes to deciding which method might be most appropriate. When it comes to data visualization tools, there's certainly no shortage of options. Do you want to develop in a text language or an interactive GUI? Do you want to let people explore an interactive chart or get right to the point with static charts? Are you looking for a data viz tool that stands alone or is tightly integrated with another programming language? And do you want to go it alone with open source or look to a vendor for support and or some other value add? Today we're going to look at what are generally considered the core plotting libraries for graphics coding in Python, R, and SAS. Although it should be mentioned that there are many other graphics libraries and frameworks for R and Python that build on the core libraries or present other alternatives. SAS also has some other data viz products, including SAS Graph, SAS Visual Analytics, JMP, and IML. All three of these languages and their associated graphics coding frameworks share some common goals. We'll see how all enable the automated hands-off production of charts from within a programming language to achieve reproducible results and facilitate scaling. You may be familiar with Hello World programs, small programs that simply display the message Hello World in different programming languages. With just a few lines of code, Hello World programs help illustrate the basic syntax of various coding languages. In the spirit of Hello World programs, then, in this presentation, we'll take a look at some Hello Graphics World programs that illustrate the basic syntax used to create fundamental chart types in SAS, R, and Python. Each of these languages has a variety of graphics frameworks. We'll be using ODS graphics for SAS, ggplot2 for R, and matplotlib for Python. Here, for example, is a SAS ODS graphics code snippet that produces a simple scatter plot from a SAS dataset with just a few lines of code using proc-sgplot. The syntax will be very familiar to any SAS programmer. And here's an example of how one can create a simple scatter plot in R from a data frame using ggplot2. The gridded gray background is from a standard R style template, akin to SAS styles and templates. You'll note a more functional syntax in the prior example, and what to me at least are more cryptic names for plot types and their properties. And while ggplot2 is almost a de facto part of R, it's still a separate library, so you have to specify a library reference. ggplot2, by the way, is short for the Grammar of Graphics and is the brainchild of Hadley Wickham, who in a recent interview interestingly mentioned that he taught SAS while teaching grad school. Finally, here's some Python code to generate a scatter plot from arrays using matplotlib. Here you'll note the syntax is a mix of functional and object-oriented. As with the Python code, there's a need for a reference to the graphics library. In the next slides, we'll take a look at scatter plots and some other fundamental chart types and explore some of the details of each language's approach. Even when trying to achieve similar results, there are some big differences between the three languages' approaches as far as how to accomplish things. So now we're going to play a little game. My R and Python knowledge is primarily from books and online courses, and there are lots of ways of coding the same thing. So to be fair to the languages, I tapped into an R Python practitioner's benchmark code for comparing matplotlib and ggplot2, making some changes as needed to get the code to run against my data sources and on my laptop. I then added my own SAS ODS graphics version of the code for comparison. Let's see what we've got. To begin, let's take a quick look at the data we're going to use in the code. We'll be using the two sample datasets SAS provides in the SAS help library. the cars, and airline datasets. R has its own versions of the SAS cars and airlines datasets, but to keep things consistent in terms of data and variable naming, I exported the SAS datasets to .csv files for R and Python. For the charting, SAS will be using the SAS datasets, while R will be using data frames, and Python will be using pandas data frames that have been loaded with the .csv data. To complete our setup, we'll also need to import the necessary graphics libraries for R and Python. Again, a nice thing about SAS ODS graphics is you typically don't have to worry about any library dependencies, at least as an end user. For SAS, global ODS graphic options are specified in the first statement, primarily to match the 12:7 screen aspect ratio, and the no border are defaults. Okay, let's begin. Bar charts are about as easy as things get, but the R syntax to generate one is certainly confusing at first glance. You'll note that plus signs are used to separate various chart components and options for ggplot2. The fill color here is specified as a hexadecimal RGB constant, which has a leading pound sign. The first statement is needed to convert cylinders from numeric to categorical to make the x-axis have a categorical scale instead of a continuous one. The Python matplotlib example is even more involved, requiring additional statements to summarize counts and resequence values and labels to display the x-axis in the desired order. Here the plt.figure call is used to set a 12:7 screen aspect ratio to match the R chart's default. While R and Python aficionados may quibble with SAS syntax, I think that SAS is clearly the bar chart champion in terms of simplicity. While not present in the other two charts, I even added labels to the bars with the addition of a simple keyword to illustrate how easy it is to do compared to, say, matplotlib. Moving on to scatter and bubble plots, the R example isn't too bad after having seen the ggplot syntax before. This is similar to the earlier R scatter plot example we saw, with the addition of basing marker size and color on the number of cylinders. Here, R also automatically generates legends for both the colors and bubble sizes. Again, the Python version of the R plot turns out to be more involved. Here, the user was required to specify a color ramp of hex RGB values in a Python list to assign colors based upon the number of cylinders, whereas R generated a range of colors automatically. Matplotlib generates neither a color nor bubble size legend. Like R, SAS will also generate a range of colors automatically, but here we've specified the beginning and ending colors in an effort to be similar to R's default. You'll note that while SAS automatically generates a color legend, it does not generate a bubble size legend. So while it gives SAS the edge syntax-wise, R wins the legend contest in this example. Okay, on to histograms. With 3 R examples under our belt, the ggplot code needed to generate a 15-bin histogram is very straightforward indeed. And matplotlib also shines when it comes to histograms. Nothing new to see here? It's probably no surprise that creating a histogram with SAS ODS graphics is also straightforward. Here I use the data label option to show how easy it is to add counts to the bars. Moving on to box plots, we see that R is equally adept at generating this chart stable. The only new thing we really haven't seen before here is the use of the alpha parameter to produce a more transparent turquoise so the lines won't be as obscured. Making matplotlib match the R box plot stylings is a surprisingly involved matter, requiring generating lists and iterating over them to modify the look of the box plot components and to generate x-axis tick labels. SAS, on the other hand, can generate box plots with aplomb like ggplot2. However, proc-sgplot does not allow one to specify an alpha value for the box plot fill color, so an RGB value for a lighter shade of turquoise was specified instead. Now we're going to switch from the cars dataset to the airlines dataset, so we have some simple time series data to work with. Here, a ggplot line chart is being produced. The new features on display in this example are an increase in the line width using the size parameter, and the use of formatting features to display 4-digit year values for the x-axis ticks. Matplotlib also has to jump through a few hoops to produce x-axis ticks with each year. SAS, on the other hand, pleasantly surprises us by generating the desired x ticks by default. SAS is generally good about making intelligent choices when it comes to plotting axis values. And that wraps up our Hello Graphics World examples. By the way, this presentation was inspired by a tweet I sent out a few years ago, comparing my SAS ODS graphics take on a famous Edward Tufte chart to R and Python recreations of the same by others that surprisingly generated a fair amount of interest from the data visualization crowd. This included Edward Tufte, the so-called father of data visualization himself, who seemed to be intrigued by the time savings aspect of the automated SAS, R, and Python approaches, while noting that there was still lots of room for improvement on publication quality results compared to his handcrafted Adobe Illustrator approach. As Tufte hinted at, highly customized handcrafted charts are great, but you really have to strike a balance with other things like time and cost. While custom charts produced using the latest and greatest graphics libraries may indeed dazzle, the additional complexity may result in errors and increased maintenance costs later. Similarly, while some may delight in exploring your interactive visualizations all day in search of aha moments, such is unlikely to be the case for the recipients of your FDA, FDIC, and academic paper submissions, who are likely to want you to get straight to your point with some nicely prepared static charts. Not to stifle creativity, but sometimes you have to consider your audience and your budget. Which brings us to the end of the presentation and the big question. So what should you use for graphics? Unfortunately, that answer depends on the situation. But hopefully we've at least busted the myth that SAS doesn't do graphics like R and Python, and shown that there's often no need to leave base SAS for your charting needs. And that is all I've got. By the way, if you visit my Twitter account, Viva SAS Vegas, you'll find mostly holiday-related examples of SAS ODS that are silly, but still illustrate some techniques that are useful for more serious charting. You may also find an occasional serious chart or two. Anyway, thanks for viewing.